Hello? Am I early?
Welcome to the Tree of Life, a visual family tree of all organisms on the planet Earth.
Good morning. You must be the new TreeTender. I am a catalog assistant and virtual interface node. Welcome to the Tree of Life.
Catalog assistant?
And virtual interface node. Calvin. You can call me Calvin. I can assist you in operating the Tree of Life.
Okay. Calvin. Let's get started.
Would you like to set up a user profile at this time?
Sure.
What is your name?
Gaia.
Greetings, Gaia. I will take your profile scan.
What?
Thank you, Gaia. Your appearance is splendid.
Thanks.
Your user profile has been created. Commencing orientation protocol.
No thanks. All right, Tree of Life. Let's see what you got. Okay. Show me albatross. How about emu? Okay, but do you have Atlantic puffin? I thought this thing was going to be bigger. You know what would be fun? Mapping the common ancestry connecting birds and whales.
May I assist you?
Everything's under control.
You are currently viewing the group that includes all vertebrates.
Yeah, I know. It contains all animals with a spinal column. Mammals, fish, birds, reptiles. There are over 66,000 such species on Earth.
Yet the vertebrata subphylum comprises less than 0.03% of the Tree of Life.
What? Only 0.03%?
The vertebrata subphylum comprises less than 0.03% of the Tree of Life.
No, I heard you. That's amazing.
This subphylum is part of the Animalia group, one of 6 main branches diagrammed on the Tree of Life. Would you like to see the rest of the Animalia group?
Sure.
Loading the animal group.
Well, I can see how big the animal group is.
Gaia.
You know, there's got to be a better way to show the scale of the tree.
Gaia.
I mean, what if we...
Gaia.
Yeah? Whoa!
Welcome to the Tree of Life. This is a 3D representation of how all life on Earth is connected.
It's huge.
We can also add the group Plantae.
The plant group is available here too? I've never seen anything so enormous.
The largest of all the sections contains the smallest of all life forms. For example, microbes.
So, you're saying this tree shows every single thing in existence?
Not just all life that has ever existed, but also their ancestry and how they are all connected.
So, I'm somewhere over here.
Correct.
What's this?
Traveling from Atlantic puffin to human.
Where are we?
The Tree of Life illustrates the relationship between all species on Earth. You are experiencing chronophylogenetic travel as we move between organisms.
Ah, so the tree charts the evolution of different species through time, and we're traveling through the family tree?
Precisely. If we had made a right at that Morgan-Eucadon back there, we would have arrived at geckos instead of humans.
So the tree branched off at the mammal's common ancestor.
Here we are, Homo sapiens.
Humans are such a small part of the tree.
You will notice that robots are not included in the tree of life at all.
Huh. Well, I guess that puts things into perspective. So, besides mapping all of this, what is the benefit of having the tree?
Salix babylonica, a deciduous tree native to northern China.
Salix babylonica?
Salix babylonica is one benefit of the tree of life. While Salix babylonica and humans share very little common ancestry, this particular species has much to do with human life.
How so?
This tree has medicinal properties of great value to humans. Salix babylonica's leaves were used as an effective remedy for aches and pains thousands of years ago. In more recent eras, scientists were able to derive new medicines from Salix babylonica, such as acetylsalicylic acid.
In other words, aspirin.
Correct.
There are so many plants listed here, though. Is that why the tree of life has to be so detailed? So that scientists can test every one for potential medicines and things? That must take forever.
No, that would not be efficient, especially for human scientists. Since the tree of life presents the relationships between species, it makes it easier for scientists to locate hotspots.
Hotspots?
Hotspots are closely related species that are likely to share beneficial qualities, such as medicinal or nutritional value. If you know where to look, you can find what you need.
So, in theory, we could use these hotspots to predict the next generation of medicines and benefits?
Certainly. Returning to platform.
Wow. This is a bigger deal than I thought. Fascinating. And I like how humans can benefit from different species too. Do other species benefit from this type of relationship?
Yes. There are extremely beneficial food-centric relationships that go beyond just human hunger. Millions of years ago, grasses and grasslands became critical habitats for mammals and birds. As grasses spread and radiated across the globe, so too did the animals that used those grasses for protection and food. As new drought-resistant grasses diversified, this created opportunities for new mammal communities to thrive. As species became extinct, the niche they once occupied is taken up by their descendants. The rise of grassland ecosystems was important for one particular group of primates. Parts of Africa became dominated by grasslands, leading to humans.
So, in a way, the fate of humanity was tied to grasses.
That is correct. There are many other such codependent relationships in nature.
Oh yeah, symbiosis.
Symbiosis, a partnership between two different species. Many non-human organisms display symbiotic behavior.
Show me on the tree.
Certainly. Acacia are able to grow in arid conditions where fires are common. They are able to live in these harsh habitats because they have formed a partnership with microscopic organisms living on the plant's roots. These organisms are able to convert the soil's nutrients into a form the plant can use as building blocks for growth. This enables acacia to flourish in dry, disturbed areas that would otherwise be unlivable.
I see. The roots of the acacia have a symbiotic relationship with bacteria normally found in the ground.
Similar to the coral reefs.
Oh, in this symbiotic relationship, the coral polyps attract a microscopic organism called a zooxanthellae, or zooxanths for short. The tiny organism lives within the coral polyp and gives it its color and makes food from sunlight, which it shares with the coral. In return, the coral protects its microscopic buddies.
This additional energy source allows the coral to grow bigger than it otherwise could.
What an amazing partnership. Like Thelma and Louise, Batman and Robin, Bert and Ernie.
I am unable to locate these species on the Tree of Life.
never mind. The coral and zooxanths create something beautiful together, something they could never accomplish by themselves. Their partnership creates homes and food for small fish, who attract bigger fish, who attract even larger fish.
The entire coral reef ecosystem depends upon this partnership between a coral and a microscopic creature.
Inspiring. Everyone depending on each other.
Humans also benefit from the coral reefs. The reefs protect the coastlines from erosion, and the fishing industry depends on the coral reef's health and longevity. This type of human dependence on nature is called an ecosystem service. All of this can be displayed by the tree.
What's happening? Oh, coral bleaching. I've heard about this.
Coral bleaching occurs when the zooxanthellae can no longer survive environmental conditions due to rising temperatures. It is no longer beneficial for them to be attached to the coral, so they leave. Without support from these microscopic creatures, the coral is too large to sustain itself. It starves to death.
What about all the other organisms that depend on the coral? We have to save the reefs.
The coral reefs are not the only ecosystem in danger. The current extinction rate on Earth is 1,000 times the historical average.
1,000 times the historical average? No. We have to do something. If this pattern continues, where would this leave us? What do we do?
I am not programmed to maintain the Tree of Life, only to navigate it. That is why you were selected for this job.
But the tree is dying.
Humanity is the only species that is equipped to solve this problem.
I don't know what to do. It's already in such awful shape, and I just got here.
I regret that I cannot be of more assistance.
The tree shows us that everything is connected, and that even a small change can devastate an entire ecosystem. Maybe it can work the other way too. Maybe small changes in targeted areas could save the tree. Let me test this. We should all be more like the coral, right? If we work together, even the smallest adjustment can be the foundation of an entire world of change. If we keep that in mind, then... Yes! There's still time!
I think I am experiencing the emotion you humans refer to as hope.
Me too. This was some first day.